Good evening, everyone. Welcome to this evening's lecture. This is a continuation of our Unit 5, and in this session, the third session of the unit, we are going to learn the areas under the normal curve. Section objectives. By the end of the session, you should be able to determine the areas under the normal curve. We have already done how to compute the units under the normal curve in the session 1 of the unit 5 of this same unit. Remember, I taught you how to compute the units, which I said the middle value is always the mean, and with the normal distribution we move in standard deviation units. We've done a number of calculations on that, so I hope you are ready for this session. This aspect has to do with the areas we cover under the normal curve, the spaces covered, how we go about the spaces covered. So pay attention as I begin the lecture on this. On this slide, we have a simplified calculation of some units which have been moved both in the one-tailed direction and in the two-tailed direction. In research, we learned that when we are testing hypotheses, we quote two major hypotheses. The first one, which is the null hypothesis, and the second one, which is the alternate hypothesis. And with the alternate hypothesis, we can formulate it in two main ways. It's either you are formulating it in one-tailed, or you are formulating it in two-tailed. And when it is one-tailed, that means the researcher or the one conducting the research want to move in a directional form. I mean, it's either the person want to go the right direction or the person want to go the left direction. Sorry, let me use the normal curve. This is not great. It's either the researcher want to move the one direction or the researcher intends to move two directions. I mean, want to move in both angles. Anytime a researcher is moving in one direction, that is the one-tailed, it's likely the researcher may go the left way or the researcher may intend to go the right way. So just moving one direction is one-tailed. That is the mean, the middle value. So moving one direction is one-tailed. But the situation where a researcher decides to move in two different directions, both towards the left and the right direction, then we say the person is moving two-tailed. So assuming the researcher wants to move two-tailed on one unit, I mean both at the left and the right, you can see we have one unit here, -1 here, we have -1 here too. So anytime it's both left and right, we say the researcher has moved two-tailed. And on this slide, we can see that the researcher has moved one-tailed because the researcher's movement is just in the right direction and is on one unit. Remember, we learned that the horizontal axis is determined in standard deviation units. So here, and this one too is a standard normal curve. That's why we have 0 in the middle. And if you have 0 in the middle as our mean, that means the person moving this direction is just one unit in the right direction. Remember, I said moving in the right direction is has to do with increasing the values, the units, and in moving towards the left direction, there will be a decrease. So we may have -1 here, -2 in that order. Okay, the summarized results here are coming from some calculations we did, and some aspects we are not going to stress ourselves, especially when it is one-tailed. So anytime it is one-tailed, you will not stress yourself. You will not do any calculation. But when it is two-tailed, you'll be doing some calculations. Anytime, let's take note, anytime it is one-tailed, you will read it from a table. And anytime it is two-tailed, you will just add the one-tailed to the other side. I mean, you will pick the one-tail and add it to itself. If one-tail you got, for the one-tailed you get, let's say 0.25, and you want it in the same direction, you want it in two-tailed, you add the 0.25 to another 0.25 to get for the two-tailed. So what I'm saying is that anytime it is one-tailed, we don't calculate. We don't stress ourselves calculating or computing manually. We have a summarized table. Then that is the last page of our book. And I've also included that page on this slide or in this presentation. So continuously, I'll keep on referring you to the table, the standardized normal distribution table. Okay. Reading from the left, under the one-tailed, we can see the content has been divided into two. We have one-tail, two-tail. So reading from the left, number one is the mean plus one standard deviation units. And remember I said anytime you see plus, that means moving one standard deviation units. And the plus signifies what? Movement towards the right direction, because we add as we move to the right direction. So if it was mean minus one standard deviation, then it will be movement towards the left direction. So in our case, what we have here is mean. Remember I said the U with an extended bar line is the mean for the population. So mean plus one standard deviation, moving one standard deviation units. When you check from the table, when you check from the standardized normal distribution table, the value you will see is 0.3413. 0.3413. On that table, we only have decimals. So the percentages in the brackets were computed manually. So here, if you want to get it in percentage, and we'll be doing this when we get to the fourth session, that is where we'll be doing the application. In some of the applications, there will be the need to multiply your results by 100. So here, we are not going to concentrate on that. Reading from the table, you always get your answer in decimals. And once again, I'm saying that anytime it is one-tailed, you can get your answer from the table. By any time it is two-tailed, when you are moving one standard deviation, just like we have at the right side, but two-tailed, you will not get this on the table. This value wasn't obtained from the table, but it is what we got here, the first value, the one-tailed that has been added to itself, or that has been multiplied by 2. So let's see. If I want the mean plus, or you can see plus or minus, meaning we are moving towards both directions at the same time, and it's in 1 unit. So plus or minus, we know when we are going the right direction is plus, and when we are going the left direction is minus. So this the mean plus or minus 1 standard deviation two-tailed, as we can see at the right side, has to do with moving to both the left and the right side at the same time. And we want you to compute the spaces covered, or the space covered. So I said that when it is two-tailed, all you have to do is check for its one-tailed and add it to itself. So if it was one-tailed, it would have been what? 0.3413. So two-tailed will be 0.3413 plus another 0.3413, because we have moved in both directions. And for the movements, the values you will see on the table, whether it is negative or positive, you get the same value, because for the table we don't have negative values on our table. On the summarized table we have presented at the back of the book, we don't have negative values. Back to the left side. The next is the mean plus still one tail, moving only one direction, moving towards the right direction because it's plus. Mean plus 2 standard deviation units equals 0.4772. This is what you will see on the table, not the percentage in the brackets. If you want the two-tailed, I said for the two-tailed, you cannot see this on the table, on the summarized table. But what you have to do is, since you have computed, you have checked the one tail on the table or from the table, all you have to do is you add the one tail to itself. So you add another 0.4772 to the 0.4772, and this will bring you the 0.9544. Let's take note of that. Mean plus 3 standard deviation units. When you move 3 standard deviation units from the mean, that is the mean plus 3 standard deviation units, because the plus there means moving towards the right direction. On the table, you will see 0.4987. On the table, you will see 0.4987. And I said anytime it is two-tailed, you add what you got for the one tail to itself. So you have 0.4987 plus another 0.4987, and this will give you 0.9974. This is what the two-tailed direction will give us. The fourth movement, the fourth area covered to the sixth area covered, looks a bit complicated. We will not get this directly on the table. We have to do some splitting and finally do some calculations. So let's go to how we can practically assess or obtain values for movement towards both the left and the right direction and the two-tailed. So all the summarized information here has been explained in detail on the subsequent slides. So let's pay attention and listen attentively. They look a bit technical, but they are not difficult. So let's pay attention. Okay, so I'm moving to the next slide. Now with each slide, I've considered the relationships as was presented to you earlier. We have one-tailed, two-tailed. So for each one-tailed or one-tailed, I'll explain how we got it from the table, and after I'll explain its corresponding two-tailed. So each of them will have their corresponding two-tailed following immediately after the one-tailed. So let's take note. So we are starting with the first relationship. Before, these are areas under the normal curve, as I've started already, and detailed explanations of the relationship between the standard deviation and the units are shown as follows. So we are going to learn the relationship between the standard deviations and the means, and this will help us know the areas we will cover under the normal curve, moving in both one-tailed direction and two-tailed direction. So anytime it's one-tailed, like I said, that means you are moving to one side, whether you are moving to the left side, or the right side. And then anytime you are moving to both sides, anytime you see both, that means we are moving towards, we are using the two-tailed. So anytime it's two-tailed, we move in both directions, both left and right. So you remember the symbol I use plus, and beneath it, below it, we had minus. So when it is two-tailed, then it means we are adding and subtracting at the same time. Okay, let's start with the first relationship. The first relationship, that is the one I explained earlier, this relationship. Now the first relationship under one-tailed is if one moves one standard deviation. If one moves one standard deviation, that is mean plus one standard deviation. So one moves one standard deviation from the mean, or one standard deviation unit from the mean to the right. To the right, the area covered is, let's consider the decimal because this is what you see on the table. And like I said earlier, this value, to get this value, you have to multiply the value obtained from the table by 100, and this will give you this. And we will be using this when we get to the applications. But for now, let's concentrate on the decimal. Okay, so on the table, you will see the decimal. If you want to see, or if you want to know, moving from, if a researcher want to move from, or a statistician want to know the value for moving one standard deviation unit from the mean, this is the value you see on the table, 0.3413. Likewise, if one moves one standard deviation or one standard deviation unit from to the left, the area covered is, you will still get 0.3413. Remember I said whether left or right, you still get the same value. So if you are going left, that is the minus, is one-tailed. If you are going right, which is plus, it is still one-tailed. So the value will be the same. So on the table, whether it is negative or positive, let's still target our 1, and that will bring us the same value. And if it's true, whether to the left or right, whether negative or positive, you will still see the same value on the table. So on the curve, on the normal distribution curve, this is the right direction, the one-tailed right direction, when we are moving one standard deviation unit from the mean. The area covered, like I said, will be 0.3413. And when we are moving one standard deviation unit to the left from the mean, you are still going to cover, the space you are going to cover will still be 0.3413. The information on the table has already been computed for us. So all we need to do is just go to the table and select the corresponding value. So if this will even come in our exams, then we are going to provide you with either the aspect we think you'll be searching for, or you'll be provided with the entire table. That's what we have been doing always. Okay, so this is the first relationship, one-tailed, and that is when we are moving one standard deviation unit, as was presented to you in a summarized form. Okay, let's move to the table and see how we can search for that value. On the table, we have the information on top to be the titles, and we are going to base on the titles on top, and the one behind the vertical line, I mean the information behind the vertical line, are also another set of titles, which will help us know the corresponding values for the various movements, I mean on the units we have covered. Anytime it's just one decimal place or two decimal places, we can get our information directly from the scores under 0.00 or 0.00. Let's take note of that. So like moving one standard deviation unit. One standard deviation unit is just like writing 1.0. So if it's just one standard deviation unit, you can trace it from the information under the 0.00. Moving two standard deviation units, the same thing, one-tailed. Moving three standard deviation units, one-tailed, you get them here. So let's see how we can get the movements moving one standard deviation units, one-tailed. So now on the vertical axis, you will search for the value 1. The value 1. So we can see 1 here. And under the horizontal title, the 0.00, let's see which value corresponds directly with the with the 1. And we can see that we have 0.3413 or 0.3413 immediately corresponding with 1.0 here and 0.00 on top. So that's where we got the decimal, the area covered from. Let's take notes. 0.3413. Okay, now let's move to the second relationship. The second relationship, still on the areas under the normal curve. The spaces, how to compute the spaces covered under the normal curve. Remember I said when it is two-tailed, we don't bother ourselves going to the table again, but rather we add the one-tailed value we've obtained already. We've searched for from the table already. So since we know movements in 1 standard deviation units, one-tailed was 0.3413. All we have to do is we will add 0.3413 for both sides. So we will get 0.6826. 0.6826. Remember, I explained this on the summarized slide. I said that when you are moving two-tail, that is when you are moving in both directions, and it will depend on the units covered, the number of standard deviation units. This second relationship is the information we have here. The two-tailed 1 standard deviation unit from the mean. And this is how we came about the answer. Since you have already computed for the one-tailed, which we have here, we have to convert this to the decimal, like I said. This is the percentage. So 0.3413 plus, that is for one side, either the left or right. But this time around, because it's both, so we are covering both. We have covered both, and we want to know the spaces you have covered. It's going to be 0.3413 plus 0.3413. And this gave us the value we have here, the 0.6826. Okay, 0.6826. Okay, so if one moves 1 standard deviation or 1 standard deviation unit from the mean both to the left and right, the total area covered is, so if you move both to the left and right, that is two-tailed, like I said earlier, the area you have covered is when we add the standard deviation units for the left and the right, and we know for either side already. We have already checked from the table. So all you have to do is you add the answer you got to itself. That's all. Okay, let's move to the next slide, the third relationship. And the third relationship will be an explanation of the second point here under one-tailed, when we are searching for moving 2 standard deviation units under one-tailed, the third relationship. And here it reads this way: if one moves 2 standard deviation units, if one moves 2 standard deviations or 2 standard deviation units from the mean to the right, the area covered is 0. Remember I said that's what you see on the table, 0.4772. Likewise, if one moves 2 standard deviation units or 2 standard deviation units to the left, the area covered is the same. Whether to the left or to the right is the same thing. Whether to the left or to the right is the same thing. So let's take notes. So if you are moving 2 standard deviation units, and since it is one-tailed, remember I've already said that you have to check from the table. Anytime it is one-tailed, we check from the table. And when the number of units we are moving, the standard deviation units we are moving, is either 1 decimal in 1 decimal place or 2 decimal places, you will be able to get them directly on the table. And if it is more than that, I will explain later. So now let's go to the table. Remember I said when it is just in 2 standard deviation units, I mean 2 decimal places or 1 decimal place, you can get it immediately under the 0.00. So here, when we were searching for the 1, remember we chose this and its corresponding value. But now we are not searching for 1. And the 2 is still in 1 decimal place. It's 2.0, the same as 2. So we will just target the 2 from the vertical axis. So let's target the 2 from the vertical axis, this 2. And what is the corresponding value? 0.4772. 0.4772. So this is the value we saw on the table. When you are moving to the right in 2 standard deviation units, the area you cover. And when you are moving to the left in 2 standard deviation units, the area you cover will be the same thing. I hope we've understood this. Now let's go to its corresponding two-tailed. Its corresponding two-tailed value. That is on the summarized slide. The information we have here. 2 standard deviation units. 2 standard deviation units. When we are moving 2 standard deviation units under two-tailed. Under two-tailed. That is our 4th relationship. The 4th relationship. That is the 4th relationship. And remember I said, because we have already searched for its one-tailed. Because we have already searched for its one-tailed, which was 0.4772. All you have to do is you add the negative and the positive to give us for both sides. So when we are moving, if one moves 2 standard deviation units or 2 standard deviation units from the mean to both the left and right units or directions, the total area covered is going to be 0.9544. 0.9544. 0.9544. And this is after you have multiplied by 100. So when you multiply your area covered by 100, that is where you get the percentage, 95.44%. So since we have moved in both directions, the area covered will be, we can see our mean here. The area covered will be the 0.4 in decimal form, 0.4772 plus 0.4772. 0.4772. 0.4772. Let me write it well for you. 0.4772. And this will give us the value 0.9544. 0.9544. 0.9544. I hope we've understood this one too. So let's move to the 5th relationship. That is when we are moving in 3 standard deviation units from the mean to either the left or the right directions. Okay, so let's move to the next slide. I hope you've understood the 4th relationship. Let's move to the 5th relationship. On this slide, which is one-tailed, it's talking about if one moves 3 standard deviation units or 3 standard deviations from the mean to the right, the area covered on the table, you see this. You will see 0.4987. Likewise, if one moves 3 standard deviation units or 3 standard deviation, I always add the units, though it's not there, but still it's the unit. So if one moves 3 standard deviation units or 3 standard deviation units to the left, this one we are just taking it in isolation, either to the left or to the right, the area covered will be on the table. We will see the same thing, whether to the left or right. Remember I said let's forget about the direction, I mean the sign, whether it is negative or positive. The negative or positive is just helping us know the direction, yet we will still arrive at the same value, the same z-score. on the curve, looking at the spaces covered, you can see we have 1 here, 2 here. So we have covered 3 spaces towards the right direction. And this one we have covered 3 units or spaces towards the left direction. And you can also get this on the table. On the table, we are going to see 0.4987. So let's go to the table. Remember I said when the value we are searching for, the standard deviation units, is either one standard deviation unit, is either in 1 decimal place or 2 decimal places, because the 3 standard deviation units can be written as 3.0, and it still fall within the category I just mentioned. So we can get this from the table directly. Let's go to the table. On the table, we have on the horizontal axis where we have the standard deviation units. When it is in 2 decimal places or in 1 decimal place, we can see our 3 here. Our 3 here. Sorry, I'm not using the pen. We can see our 3 here when we have moved in 3 standard deviation units. And under the 0.00, the 0.00, we can see the corresponding value to be 0.4987. 0.4987. That is what we just saw on the table. So 3.0 or 3 standard deviation units can be read from the table directly. So let's take note of that too. Now let's move to the C's relationship. The C's relationship. The C's relationship. And that one too is two-tailed. On the summarized table, this is what we are talking about. I'm going back on the summarized table, talking about the two-tailed 3 standard deviation units. We are referring to the information here. And since we already have the one-tailed, at the end of the day, we are supposed to add this to itself. So 0.497 to another 0.497 will give us this value. So let's see how it has been done on the table, on the slide, sorry. So on the C's relationship, since we are moving two-tailed, so the description is, if one moves 3 standard deviations or 3 standard deviation units from the mean, both meaning we are going to both directions, both left and right directions has been covered at the same time, to the left and right, the total area covered is, let's concentrate on the decimal, 0.9974, 0.9974, the same thing. And in percentage wise, it means 99.74%. Let's take note. And I said you will not see the percentage on the summarized table, but rather when we are doing the applications, we will be converting them to percentage. We have to multiply by 100 to get it in percentage. So I said, since we have already seen one side on the table, which is when we convert this to a decimal, 0.4987. You add it to itself, so another 0.49 plus another 0.4987, and this will give us the value here. You can check and see, confirm if it is the same thing. So that's how we got the C's relationship, two-tailed 3 standard deviation units. Okay, now let's go to the 7th relationship. The 7th relationship, still on the areas under